Imagine we want to create a private chat line between our main web page and a mini website inside it, called an iframe. We set up a two-way channel using something cool called a message channel. Think of it as having two walkie-talkies. One stays with us, and we send the other to the iframe. We tell our walkie-talkie, port 1, to alert us whenever we get a new message. Once our iframe is ready, we slide the second walkie-talkie, port 2, under its door. The iframe picks it up and sends back a friendly hello from the iframe, to let us know it's ready to chat. Imagine you want to chat with someone in the next room without opening the door. You set up a two-way pipe, so you can send and receive messages. That's what we're doing here with a web page and an iframe. We're using a message channel to create this private communication line. When the iframe is ready, we hand it one end of the pipe, port 2, using a magic word in it. Now, whenever you type something and hit that button, your message zips through port 1 and pops up inside the iframe. Cool, right? Let's imagine we're dealing with a tiny office placed inside a huge company building, and that office is our iframe. There's a special intercom system that connects this little office to the main workspace. When the main office sends a message through the intercom, our iframe office listens for that ping. Once a message is heard, it's picked up, read, and responded to. Essentially, the iframe office sends back a confirmation message saying, "Got it and handled it." It's like a mini conversation between two separate but connected offices. Imagine you're getting messages from various corners of the web, but you want messages only from trusted friends, right? That's what our code is doing here. It's being cautious, only accepting messages from a specific origin we trust. But there's a tricky part. Messages come in different shapes. If we get a weirdly shaped message, not the object we expected, we're dismissing it, no second thought. Lastly, it's like hanging up the phone after a call. Our code hangs up on the port when it's done, avoiding any unwanted eavesdroppers lurking in the digital shadows. Imagine you're sending a message from your phone to a friend's phone asking them to do something. Once they've done it, they text back to say it's done. That's what's happening here with code. The main page is like your phone, and the iframe is like your friend's phone. We send a perform action message to the iframe and wait for a reply. And look! Once the iframe gets the message, it does the task and sends back a action performed confirmation. It's like texting but in the world of web pages. Imagine you're passing a note in class but want no one else to read it, right? So we're doing the same thing with a worker in code. We create a secret channel and send a message, in this case, it's an array buffer. The worker gets the note, doodles on it, like, setting the first entry to 2. Then it sends it back through the channel. Our main thread catches it, and voila, we see the change. It's like passing notes, but for web pages to talk in secret. Check this out. We're making a web worker communicate with the main page. It's pretty cool. First, we create a worker and a new message channel. The channel's got 2 ports, right? So, we use port 1 to listen for messages from the worker. Now, when the main script sends a message, it hands over port 2 to the worker. The worker grabs that port and uses it to send back a message. It's like tossing a ball back and forth. Really nifty for complex tasks without blocking the main page. Hey, you know how we keep our phones running smoothly by closing apps we're not using? It's similar with web development. To prevent memory leaks, we need to tidy up any open connections. So, if we have a port 1 that we're done with, we just call port 1 close, to shut it down. And if a worker's job is finished, a simple close, in its global scope turns it off. Same goes for any shared worker or dedicated worker in the main thread, where my worker terminate, stops it from running. It's like housekeeping for your code. Imagine you're passing notes in class, but instead of paper, you're sending objects, like a picture with your name and age scribbled on it. That's what we do with web pages and iframes when sharing complex info like user profiles. We create a special channel and through one of its ports, send a structured note, an object with name and age, to an iframe. The iframe catches the note, reads it, and can even scribble back a response. It's like a high-tech, secret conversation between two parts of a web page. When you're dealing with messages from different sources, it's crucial to play it safe. Like, imagine getting a letter and just blindly trusting it without checking the sender. Bad idea, right? So, what this code does is act as a bouncer. It checks the message's origin and ensures it's from a trusted source, in this case, example.com. If it's not, it's a no-go. It also checks if the content looks good, so no weird stuff gets through. Only the right messages get VIP access to the process message party,